Okay, so now we're moving on to complex numbers, where we're going to express in terms of I. So what is the square root of negative 25? And let me remind you, I said it once earlier, but to help keep things clear on the test, the I is only for square roots, okay? Square roots of negative numbers. So if you see a fourth root of a negative number, the answer is not real, okay? But if you see a square root of a negative number, then you are able to evaluate it. So just keep that in mind on your test. So what is the square root of negative 25?
5i.
Very good. Square root of 25 is 5, and then the square root of the negative means you pull out an I, because you learned that I equals the square root of negative 1, right? So you can technically think of this as square root of negative 1 times the square root of 25 if you want to help you get your answer. Okay, what about the square root of negative 11?
It's the square root of 11i.
And you can write it either way. So you can either put the I afterwards or the I beforehand. The key thing you cannot do is this. Why is this answer wrong?
Because I isn't included in the radical.
So as long as you put I outside the radical, and it does not matter if you put it before or after the square root of 11, it just cannot be inside.
Negative 11.
Negative 11. Why did you not include I in your answer?
Because the negative sign is outside of the radical.
Excellent. How about the square root of negative 49 in number 36? What would that answer be?
7i.
And why did you include I in your answer?
Because it's a negative inside of the square root.
Exactly. So really, we're using the same rules you learned for square roots before, right, at the beginning of this lesson, except that now sometimes I is involved if you're doing a square root of a negative number. So how would you simplify number 37?
Would you break it apart and make it like 3 times 9 times a negative 1? And then that way you can square root the 9 and bring out the 3.
So bring out a 3. So the square root of 3 stays. This 9 becomes a 3. The square root of negative 1 becomes an I, right? And then when you multiply all that together, what is your final answer?
It gives you 24 square root of 3, and then would the I be on the outside? It would be on the outside of the square root because it's not a part.
So you could either put it like that or put it like this, for example. I sometimes write the I's in front of the radical because I would personally be afraid that I would forget to use that right arrow to move outside the radical if I was typing it into my math lab. But it is perfectly valid to have it at the end as long as you do not put it inside the radical. Now, when you're multiplying and dividing with radicals, it is important that the radical you're working with is of a positive number if you're dealing with square roots. So what I mean by that is the rule only works that you can multiply them together or divide them together when they're real, not when they're imaginary. So the first thing you need to do is actually simplify each radical, and then you can go ahead and do the multiplication. If you multiply them as is, it's very possible that you'll get the wrong answer. So you might get the right answer, but you might also get the wrong answer. So it's better to kind of aim for the right answer every time, right, by simplifying them first. So how could you simplify the square root of negative 5?
I.
Pull out an I, right? Oh, it's feels very violent in this lesson, right? We're pulling out a lot of I's. Just the letter I, right? Not our actual, not EYE I's. So you will not be harmed, right? Do I need to say that at the beginning of the lesson? You will not be harmed by participating in this lesson. Okay. How about the square root of negative 35?
Same, you pull out the negative.
Okay, now when we multiply them together, we have I times I. What is I times I on the outside?
I squared.
I squared. Very good. And then what is, it's the square root of 5 times the square root of 35.
The square root of 175.
Now we still have more work to do. What does I squared equal?
-1.
-1, good, because I is the square root of -1. You can think about if you square both sides, that means I squared equals -1. So now you have a negative on the outside. You don't need to write the 1. And then let's break down the 175. What's the largest perfect square that goes into 175?
25.
25. 25 times what?
7.
Good. So then, what is the square root of 25?
5.
5. So the final answer would be -5 times the square root. Number 39. Once again, let's simplify each radical first and then multiply. So what is the square root of 36?
6.
Okay, what is the square root of -1?
I radical 1.
It would be I radical 1, but what is the square root of 1?
1.
1. So it really just becomes I. So then what is 6 times I?
5.
6i.
6i. Really not much going on in that problem compared to the last one anyway. Nice job, guys. So let's try number 40. We're going to simplify each radical. In fact, I'll give you a minute. See if you can simplify each radical and then see what cancels out when you divide. So how could you break down the square root of -90? Vivian, did you get it?
Yeah, I'm trying to figure out like I know what I'm doing, but like explaining it is
Okay.
an issue.
That's fine. Well, what did you write as your next step? You can just read it from your paper.
I put I in front and
Okay.
took away the negative of it.
Okay, good. And then can you break down 90 at all?
Yeah, I broke that down into 10 times 9.
Okay, perfect.
And then you can break the 9 down to 3.
So I'm going to write it as 3i
Right.
square root of 10. Yes. Okay. And then what could we do in the denominator?
I only worked the top on the
Okay.
first.
No problem. Someone else want to jump in and help us with the denominator?
Make that a 5i.
So pull out the I. So I times the square root of 5. Okay, so now what can we do? Does anything cancel out?
The i's.
The I's cancel out for sure. Anything else?
Can you divide the 10 by 5?
You can, because they're both inside a radical. So technically what you're doing, you know how we normally take a fraction and then we split it up into 2 different radicals? Here you're actually kind of doing the opposite. So you're doing it in your head. You're probably not writing this out, but you're actually combining the 2 radicals back into one in your head without realizing it, because you probably did not picture that. But then 10 over 5 is actually what? 2. So I certainly would not expect anyone to write this step, but that's technically kind of what you're doing, that you're dividing them. You're using the quotient rule there. But yes, so you can basically think, okay, I just divided the numbers. That's what you did. Good. So that would be your answer, 3 times the square root of 2. Okay, number 41 and 42. How do you know, even if the word add wasn't there, so even if there were no instructions, how would you know that you were adding in number 41?
The addition sign in the middle.
Correct. Even if there were no instructions, how would you know that you're subtracting in number 42?
Subtraction sign.
Okay, what if I made up, I'm just going to make up a random problem. 2 minus 7i times 3 plus 4i. Even if there were no instructions, what operation am I doing there?
Multiplication.
Okay, how did you know I was multiplying there?
Just from previous classes, I guess.
Yeah, if there's
Knowledge.
no sign there, the assumption is that it's multiplication. I'm making a big deal of it because on problems like numbers 41 and 42, I can't tell you how many times students accidentally multiply even though all they have to do is add or subtract. So make sure you pay attention. I know I did this when we did polynomials also, that make sure you pay attention to what sign you have in between the parentheses, right? If it's a plus sign, add. If it's a minus sign, subtract. If there's no sign, that's when you multiply. Okay, so in 41, we're just adding, which means we're combining like terms, right? So what is 8 plus 3? So we're going to combine our constants together and then combine the imaginary parts with I together. So 8 plus 3 gives us
11.
11. And then negative 8i plus 5i.
Negative 3i.
Very good. You are required to write your answer in that format. So make sure you pay attention to the fact that when you're dealing with complex numbers, we always ask you to write your answer in the form a plus bi. So the real part first and the imaginary part second. So we don't want you to write negative 3i plus 11, even though it's mathematically equivalent, it's not what we're asking for. Okay, for number 42, whenever we're subtracting, you have to be careful with the signs. So I sometimes recommend distributing the negative as your first step and then combining like terms. You're not obligated to do this, just something that I find works to avoid making mistakes with the signs. So 3 plus 9i, if you distribute the negative, it becomes minus 5 plus 9i, right? Because it changes all the signs after it. But now you don't have to worry about what's going on. You're just combining like terms, right? So what is 3 minus 5?
Negative 2.
Mm-hmm. And then what is 9i plus 9i?
Plus 18i.
Exactly. And then that would be your answer. Negative 2 plus 18i. So help me out. What do we need to do in number 43?
You distribute that negative.
Good. So what does that give us?
You got 9 minus 14 minus 7i.
Good. And then what would you do from there?
You do the 9 minus 14, which you get negative 5 minus the 7i.
Very, very good. What about number 44? How would you approach that?
You would write it out to where it's like two of the same things.
Very good. So 8 minus 6i times another 8 minus 6i, and then we're going to FOIL it. So what do you get when you FOIL? What is 8 times 8?
64.
8 times negative 6i.
Negative 48i.
Negative 6i times 8.
A negative
48i.
Another one. And then negative 6i times negative 6i.
Positive 36i squared.
Excellent. Now we need to look and see if we can simplify or combine any like terms here. So what can we do?
You can combine the negative 48i's.
So what is negative 48i minus 48i?
Negative 96i.
And then what about the 36i squared? What can we do with that?
Times negative 1.
Exactly. The I squared becomes negative 1. So the whole thing really becomes minus 36, right? Because what you can think of is when the I squared becomes negative 1, you keep the coefficient the same, but you change the sign. So if it was negative, it would become positive. Since it was positive, it became negative. So then what is our final answer?
28 minus 96i.
Good. So now the 64 and the minus 36 combine to 28 minus 96i, and it must be written in that order, right? A plus bi for every answer. Number 45. Finding quotients is actually similar to what we did earlier when you rationalize the denominator. So when there's only one term in the denominator, you can multiply by I. Okay, kind of like when you have a radical, you just multiply by whatever the radical is. So here, you can multiply by whatever the complex number is, which in this case is just I. That works if you only have one term. So here, 8 times I is 8I. And what is I times I?
I squared.
And what did we just talk about? What does I squared equal?
-1.
Okay, so what is 8I divided by -1?
Negative 8I.
Exactly. That would be it. Now let's try one that's a little bit more complicated. Now we have multiple terms in the denominator. So we need to multiply by the conjugate. So what would be the conjugate of 7 plus 8I?
7 minus 8I.
Very good. Now the good news is in the top, it's being multiplied by 1. So that doesn't really change much, right? So your numerator is just 7 minus 8I. But in the denominator, we're going to need to go ahead and FOIL. So what is 7 times 7?
49.
And then 7 times negative 8I.
Negative 56.
56I. And then 8I times 7.
Positive 56I.
Good. And then the last term, positive 8I times negative 8I.
Negative 64I squared.
Good. So what can we do in the denominator?
Well, you can combine, well, I guess cancel out the 56.
Since one positive is one negative, they cancel out. And this is good news because our goal, remember when you're rationalizing the denominator, your goal is to get the radical out of the denominator. Here, when you're dividing by a complex number, your goal is to get I out of the denominator, right? Which is what we're working on. So what do we know about I squared?
Negative.
So if this is really -1, then this whole last term becomes what? 49 and then what?
Plus 64.
Good. And what is 49 plus 64?
113.
Good. Are we done?
No.
No, why not?
You have to separate into two fractions.
Yes, since they want that final answer in the form A plus BI, it can't all be over C, for example, like it is now. So you have to split it up. A and B are allowed to be fractions, so each term is going to get divided by 113. So you could write 7 over 113 minus 8 over 113 I. If it's simplified, you'd have to simplify it, but 7 and 8 do not go into 113, so you are good to go. They don't have any common factors either. What's negative 6I times 9I?
Negative 54 I squared.
Negative 54I squared. Good. And what does I squared equal?
Negative 1.
So overall, what is your answer?
54.
54. There you go. They just wanted to see if we were paying attention.